Hey y'all, in this video we're going to take a look at the Josephus problem. And in this lesson we want to look at making conjectures. So the first thing we're going to talk about is what is a conjecture. So in mathematics people make conjectures. It's an idea that you think might be true, but you don't know for sure. Make sure you write that down on your notes. Again, it's something you think is true, but you're not sure. Like, that's the first step of the scientific method. Like, I think this is true, I'm going to test it out. So conjectures are very important in mathematics, and making conjectures is something you can be doing even as a math student. Okay? We're going to watch a little bit of this video, and then your task with this is to continue working with different numbers of starting people to see if you can find a pattern and then make a conjecture. Okay? So let's watch this first part of the video.
So it's called the Josephus Problem. It's based on something from history. There was a group of Jewish soldiers who were surrounded by the Roman army, and they didn't want to get captured, so they decided to come up with a system to avoid getting captured or suicide. So they'd sit in a circle, and the first man would kill the guy to the left of him. The next remaining living person would kill the next remaining living person with their sword, and they'd go around like this until there's only one person left, and then the last person would have to commit suicide, of course, rather than get captured. And the story, at least the story I was told, I'm not sure this is historically accurate, was that Josephus preferred capture to suicide, but he worried that if he said this, the other soldiers would turn on him. And so he wanted to figure out where should he sit within this circle in order to be the last man living, and then he would surrender rather than kill himself. That was the problem. It's a little tricky, so let's do a smaller example. Let's say there were 7 people. And so just to be clear, the way it works is person number 1 kills number 2. Person number 3 kills 4. 5 kills 6. But now things get a little harder to kind of see in advance, because 7, there is no 8, so 7 kills 1. 3 kills 5. 7 kills 3. So 7's the winner. 7's the last one left over. For Josephus, there were 41 people. He needed to figure out where to sit. The mathematical problem is if there were n people, where's the winning seat? When I learned this problem, I was in high school. And it was one of the first problems that got me to understand how you approach difficult and math problems where you don't know the answer in advance, where someone hasn't shown it to you in advance. And it was a professor of mine. His name was Phil Hanlon, who played a big role in kind of leading me to math. And he suggested what we should do is we should gather data. Just take various values of n and just do it by hand and start looking for a pattern. I don't know, maybe we should just do that. N is the number of seats, and W of n will be the winning seat. And so what we know so far is that n is 7, W of n, it turns out, is also 7. And so what I would do is I'd start doing some other values. So I don't know, why don't I do 5? So 1 kills 2, 3 kills 4, 5 kills 1, 3 kills 5, the winner is 3. I guess there was no reason for me to skip 6, so why don't we fill in 6? 6 kills 2, 3 kills 4, 5 kills 6, kills 3, 5 kills 1, the winner is 5. So if you're watching, you might already start to notice some patterns. For instance, they're always odd. I mean, that's maybe the first thing you notice. And you can start to ask them, well, why are they always odd? And maybe you can already see that, right? The first loop around, all the even people get killed. So you can even with just a tiny amount of experiments start to see some patterns.
So you don't want to sit in an even seat.
Don't sit in an even seat. No. And maybe we're even getting some glimmers of other patterns. But before I really try to phrase those, I'd like to fill in the table a little bit more. So let's do some. So if there's only one person, well, that person's the winner, so that one was easy. If there's 2 people, 1 kills 2, 1's the winner. If there's 3 people, 1 kills 2, 3 kills 1, 3's the winner. If there's 4 people, 1 kills 2, 3 kills 4, 1 kills 3.
So I want you to continue working with different numbers of starting people and see if you can find a pattern and then make a conjecture. And then back to the actual Josephus problem is with 41 people, where does he need to sit so that he ends up being the last one alive? So work on that. I've given you some space on your notes paper to kind of work around with that and see what you get. Then when you kind of finish that, or when you want to know the answer, go back to Schoology and watch this video called the Josephus Problem. And I will embed it there at the point where we left off, so you don't have to watch all that first part again. Okay, so if this was interesting to you, go and watch the final answer to the problem on Schoology. And you are done with Unit 0. You have one final thing to do here on Schoology. You need to go to the end of Unit 0 reflection. That is going to open up a Google form for you to reflect on how you did in Unit 0. We don't get better unless we reflect on how we did and see where we need to improve. And so at the end of each unit, there will be a reflection to think about how you did and what you might need to do better next time. So make sure you complete that as well. You've made it to the end of Unit 0. Congratulations.